Beneath the bustling streets of our towns and cities, there lies a hidden world. It is a vast, unseen network. Tunnels, pipes. This is the sewer system. It is one of humanity's most vital creations. It works silently, day, night, performing a task essential for our survival. Without these systems, our modern world could not exist. Our homes would be unhealthy. Our streets would be unclean. The rivers, the oceans. This system is the unsung hero of public health. The purpose of this intricate network is simple. It is to carry away the dirty water we produce. Every time we wash our hands, flush a toilet, run a factory, we create wastewater. This water cannot simply be discarded. It must be carefully managed and transported to a place where it can be made safe again. This journey is a remarkable feat of engineering, gravity, clever design, constant maintenance. We will explore this hidden realm. The smallest household, drain, the largest treatment plant. Look around your community. The clean streets, the parks, the healthy rivers, all are connected to this invisible infrastructure. The health of every living thing, from the smallest insect to the largest mammal, depends on clean water. When we build and maintain our sewers correctly, we are not just protecting ourselves, we are acting as stewards for the entire ecosystem. We are preserving the delicate balance of the natural world. This is a responsibility we all share, a promise we make to future generations. In this exploration, we will demystify the world of sewers and drainage. We will look at what wastewater is. Wastewater is a simple name for a complex mixture. It is the water we have used and changed. There are three main types, each with its own character and challenges. The most common is domestic wastewater. This is the water that flows from our homes. It comes from our kitchens, our bathrooms, and our laundry rooms. It carries with it the remnants of our daily lives: soap, food scraps, human waste, and cleaning products. While it seems harmless in small amounts, the collective flow from thousands of homes is a powerful and potentially dangerous force. Then there is industrial wastewater. This is the byproduct of our manufacturing and production. Factories, power plants, workshops. This water can be far more hazardous than domestic waste. It may contain heavy metals, toxic chemicals, oils, and other pollutants. If this industrial effluent were to enter our rivers directly, the consequences would be devastating. It could poison aquatic life, contaminate drinking water sources, and render entire ecosystems barren. Therefore, it requires special handling and often pre-treatment before it can even enter the main sewer system. In places where homes are few and far between, a large sewer network is not practical. Here, people have developed clever, small-scale solutions. These are called on-site systems. The simplest of these is the cesspit. It is essentially a sealed, underground holding tank. All the wastewater from a house flows into it, and there it stays. It is a basic container, with no outlet and no treatment. When the cesspit becomes full, it must be emptied by a specialized vehicle. It is a simple but effective way to contain waste where no other option exists. A more advanced solution is the septic tank. This is a marvel of simple biology and engineering. It is a watertight container, usually made of concrete or plastic, buried in the ground. Wastewater flows into the tank at one end. Inside, something remarkable happens. Heavy solids sink to the bottom. Sludge, lighter materials like grease and oil float to the top. Scum. In the middle is a relatively clear liquid layer. This separation is just the beginning of the process. Within the septic tank, a hidden ecosystem of bacteria gets to work. These microorganisms are anaerobic, meaning they thrive in an environment without oxygen. They feed on the organic solids in the sludge, slowly breaking them down and reducing their volume. This natural process is a form of primary treatment. It is a silent, continuous digestion of waste. The scum layer on top helps to prevent odors from escaping, and it maintains the oxygen-free conditions the bacteria need to survive and do their work effectively. After a few days in the tank, the clearer liquid flows out through an outlet pipe. This outlet is positioned to draw water from the middle layer, leaving the sludge and scum behind. The liquid, known as effluent, is not yet clean. It still contains bacteria and dissolved pollutants. It flows from the tank into a special area called a leach field. It flows from the tank into a special area called a drain field. This is a network of perforated pipes laid in shallow, gravel-filled trenches. Here, the effluent slowly seeps into the soil, which acts as a natural filter, completing the treatment process. The construction of this network is a precise and demanding task. It begins with digging a trench. The trench must be at the correct depth with a steady, gentle slope. This slope, or gradient, is critical. Too flat, solids settle and block the pipe. Too steep, liquid races, leaving solids behind and scouring the pipe. The pipe is laid on a carefully prepared bed of sand or fine gravel. This bedding provides uniform support, protecting the pipe from the earth above. Where pipes change direction, or where several pipes join, we find manholes. Manholes are the eyes and ears of the system. Through them, workers inspect for damage, clear blockages, and perform maintenance. Manholes are built to maintain smooth flow. The channel at the bottom is shaped to guide water and prevent turbulence. They are topped with heavy cast iron covers strong enough for traffic. In some flat landscapes, gravity isn't enough. Pumping stations are built. The heart of the system. Powerful pumps sit in deep underground wells. As the well fills, pumps automatically start. They lift wastewater to higher elevations so gravity can take over again. These stations move wastewater long distances to the treatment plant. Once a sewer system is buried, it is not simply forgotten. It must be tested and monitored to ensure it works as designed. Before a new pipeline is put into service, it undergoes a series of rigorous checks. A simple light test, a lamp shown down one end viewed from the other, checks straightness and obstructions. More importantly, the system must be tested for leaks. Often done with an air test or a water test, the pipe is sealed and pressurized. Any drop in pressure over time indicates a leak. Even a well-built system faces constant threats from the world around it and the waste within it. Corrosion is one of the most insidious problems. Waste decomposition releases gases like hydrogen sulfide. That gas plus moisture can form sulfuric acid. The creation and upkeep of a sewer system is a task for engineers and public workers, but its success depends on everyone. The community has a powerful role to play at every stage. During planning, local leaders and residents must be involved. Their local knowledge is invaluable. They know where water collects during storms. They know where new development is likely to occur. By participating, they help ensure the system meets the community's needs for years. Responsibility doesn't end after construction. Daily habits affect the sewer system's health. Educate the community on what can and cannot go down the drain. Cooking oil, grease fat. These cool and solidify, creating stubborn blockages. Wet wipes, paper towels, cotton swabs. These don't break down like toilet paper and cause clogs. Show, do not flush graphic. Wet wipes, cotton swabs, bottle of oil. A simple rule, only flush the 3 Ps. Pee-poo toilet paper. Safety is shared responsibility, especially for workers. Working in sewers is hazardous. Confined spaces can contain poisonous gases or lack oxygen. Trenches can collapse without warning. Strict safety protocols are lifesavers. Test the air before entering a manhole. Use safety harnesses. Have a team member monitoring from the surface. Workers must wear personal protective equipment, or PPE, gloves, boots, masks. PPE protects from contact with raw sewage. The goal: protect our most precious resource. Clean water, from the smallest septic tank to the largest urban network. Each component plays a part. Understand how systems work. Use them wisely. Support investment to maintain them.